चल दिया। हाँ, so now we have the problem of the indefinite integration, which is sec square x upon secant x plus tan x whole raised to 9 by 2 dx. So as we can see, the in the new denominator we have secant x plus tan x. So in order to integrate this function, we will need either its derivative in the numerator or the function itself, or the some power of that function. So let we denote this function by t. So now if we calculate its derivative, it comes out to be thus we will need to have the derivative in the numerator. As we can see, we have secant square x in the numerator. However, if you simply add secant x tan x in the numerator and then subtract it, we can see that the first term which we will have, we can easily integrate it. However, the second term which would be there, secant x tan x upon secant x plus tan x whole raised to 9 by 2 is somewhat difficult to integrate. So hence what we'll do is we'll produce 2 secant square x in the numerator, so that we can have two terms which can be expressed in the form of derivative of secant x plus tan x. Thus we will do half of 2 times secant square x upon secant x plus tan x raised to 9 by 2. This we can write in the form of half of secant square x plus secant x tan x upon secant x plus tan x raised to 9 by 2, and half of secant square x minus secant x tan x upon secant x plus tan x raised to 9 by 2. For the first term, we can see that we can integrate it easily because it's simply the derivative in the numerator and the function in the denominator. So this will be simply dt upon t raised to 9 by 2, which will be nothing but equal to half of 1 upon t raised to 7 by 2 into 7 divided by 2. Now the second term which we have over here, which is half of integral of secant square x minus sec x tan x upon secant x plus tan x raised to 9 by 2. Now as we can see that the numerator is not either in the form of its derivative or some power of that function. So we will express it in the form of secant x into secant x minus tan x. As we know that secant square x minus tan square x equal to 1, therefore secant x minus tan x can always be written in the form of 1 upon secant x plus tan x. So now what we have is half secant x upon secant x plus tan x. Thus if we multiply it by the function secant x plus tan x in the numerator and the denominator, we will have secant square x plus secant x tan x upon secant x plus tan x whole square. So now even the second term is reduced in the form of the derivative of the function and the power of that function. So the second term can now be written as half of secant square x plus secant x tan x dx upon secant x plus tan x raised to 9 by 2 plus 2, which is nothing but 13 by 2. So thus we will have it form of the dt upon t raised to 13 by 2, which will be nothing but half of 1 upon t raised to 11 by 2 into 2 upon minus 11. So now the complete integral we have is in the form of half of minus 2 by 11 raised to t raised to 11 by 2 plus minus 2 upon 7 into t raised to 7 by 2 plus c. Substituting this t back in the equation, we will have minus of 1 by 11 secant x plus tan x raised to 11 by 2 plus 1 by 7 into secant x plus tan x raised to 7 by 2 plus constant. So thus we have seen that we have solved this equation in the form of the function. Even if you want to simplify it further, you can write it as 1 upon secant x plus tan x whole raised to the bigger power, which is nothing but 11 by 2 into 1 by 11 plus 1 by 7 times of secant x plus tan x whole square plus c. So now we have this final form, the indefinite integral of the function as here.